All right, so coming up, we need to solve the count-bound inequality. Solve the inequality which is 6b smaller than 24 or 4b plus 12 is greater than 4. Right. So as you can see here, we have two parts. Let's call this part 1 and part 2. Right. So first let's solve for part 1. We solve for part 1. We got 6b is smaller than 24. So we times 1 over 6 on each side to get rid of this coefficient of b. So we got 1 over 6 times 6b is smaller than 1 over 6 times 24. And 6 over 6 will be 1. So it becomes 1b is less than 24 over 6. And 1 times b is just b itself. And 24 divided by 6 is 4. Yep, so that's what we got from the first part. And for our second part, so for part 2, we got 4b plus 12 is greater than 4. All right. So since we want to have b only be on one side, so we move the 12 to the other side. So in order to do this, we will minus 12 on each side. Minus 12, 4 minus 12, and plus 12 minus 12, it just becomes 0. So we only got 4b on the left-hand side, which is greater than 4 minus 12, which is negative 8. Right. So similar to part 1, we times 1 over 4 on each side to get rid of the coefficient of b. 1 over 4 times negative 8. And 1 over 4 times 4 is just 1. So we only got b on one side. And negative 8 divided by 4 is just negative 2. Right. So that's what we got from the second part. So now we just need to combine the both inequalities. Combine the result from part 1 and 2. We have b is less than 4 or b is greater than negative 2. And if we will present it on a vertical line, it will somehow look like this. So that's negative 2, and that's b. We want b is smaller than 4, so that's this area. And we also want b is greater than negative 2. Which is this area. So we can conclude that b is less than 4 or b is greater than negative 2 is same thing as negative 2 smaller than b is smaller than 4. So which means b is greater than negative 2 but less than 4. Yeah. And I think that's all we got for this question. And let's leave a comment there.